Hey everyone, Mrs. Edstrom here. We are looking again at scale factors today. We're on page 36. So page 36 if you were in the note packet with me. And we're talking scale factors, so make sure you fill out today's date. And our essential question today is, how do I identify the scale factor? So how do I find that scale factor? Let's write that. How? Oh my goodness. I forgot how. Let's rewrite this. Okay, there we go. How do I find the scale factor? How do I find the scale factor? So let's remember what a scale factor is. We're going to define this one more time. So a scale factor, we often are going to simplify that. You might write SF for scale factor, and that's fine with me. It is a multiplier. What does it mean to be a multiplier? Yeah, a multiplier is a number that we multiply with. That's really it. It's a multiplier, so we're going to multiply with it. And it is the ratio. It is a ratio, which we are going to write as a fraction. You can write ratios with a colon as well, or the word 2, but we're going to stick with a fraction for scale factors. And it is the ratio that compares corresponding side lengths. In two similar figures. So similar figures are when we have the same shape. So like you'll notice this rectangle up here, it looks very different than this one down here. These would not be similar because the ratio between the two sides is going to be different. You can see these two are closer in length than these two over here. So these would not be similar. But these ratios happen to be the same here. That's what makes these two rectangles similar. We've been talking about corresponding side lengths. So remember, corresponding side lengths are when we talk about the same relative sides. So for example, the shorter side of the rectangle here corresponds to the shorter side of the rectangle right over here. So those would be the corresponding sides. And then the 12 and the 24 would also be corresponding sides. And the scale factor, it is the ratio between these two sides. So it's between two different shapes. That's a different ratio than what would be between the two sides in the same rectangle. So we're looking at these two. It's a multiplier. So the first thing we have to identify is the original and the copy. Whatever is the first shape, since we read left to right and up to down, it would be the one that is on top if they are above and below each other, or it would be the one to the left. So in this case, this is the original. Sometimes I like to label it just to remind myself as I'm working through the problem. And the second one is our copy. Also, if you identify original and copy and you accidentally mix it up, that helps us to know that you did the math correct, but maybe just identified the wrong original. So, finding scale factor. It's a multiplier. It is how we go from the 4 meters to 8. So one way that you can figure this out is you can find, well, what would I multiply 4 by to get 8? Some of you already know that. But sometimes it's going to be a fraction and it's going to be harder to identify in our head. So we write a fraction. So when we are writing our scale factor, we write a fraction, and our fraction has the copy over the original is how we write it. The copy over the original. So in this case, the copy is that second number, the 8, and the original length was the 4. And so we're going to write over 4. Now the reason that this works, as we said, it's a multiplier. So we want to know 4 times something equals 8. We can do math in reverse. We're going to learn inverse operations later on this year. And we can do math in reverse, meaning the opposite of multiplying is dividing. So I could also take that 8 and divide it by the 4 to come up with our multiplier. And that's all we're doing here. A fraction is division. So this is 8 divided by 4. I can do that division and get a whole number. Sometimes we want to reduce. So in this case, we try to start reducing fractions. And so when we reduce, we can divide 8 by 4 to get 2. And we can divide 4 by 4 to get 1. It is a whole number, 2 over 1. So that means in this problem, my scale factor is 2. And you maybe already knew that because 4 times 2 is 8. And it's the same for this one. 12 times 2 is 24. So when you're finding the scale factor, you're writing this fraction, the copy over the original. And you can use any of the sides. If they're similar figures, the ratio will be the same for all corresponding sides. So, when finding scale factor, write the fraction. Step 1, write the fraction. Copy over original. Original. There we go. Oh my goodness. There we go. Original. That's not how you spell it. Copy over original. There we go. Copy over original. Then reduce. Sometimes it will be a whole number. Sometimes it'll be a fraction. It could be 3/5. It could be 6/8. It could be any fraction. But you have to write the fraction, then reduce the fraction.